Hello everyone, my name is Rahul and welcome to my channel DevOps Forge. Let me ask you something. You know how sometimes you order food, it looks amazing, smells incredible, and then it just sits on the counter for 45 minutes because nobody is there to deliver it. That was software development for about 40 years. Developers built great software and it just sat there, waiting while a completely separate team figured out how to actually get it to users. Sometimes that wait was weeks, sometimes months, and half the time when it finally shipped, something was broken. DevOps is the solution to that problem. And in today's video, let's understand what is DevOps and why DevOps was introduced. Starting with the first topic, the world before DevOps. Picture a restaurant where the kitchen and the waiters are two completely separate departments. Different managers, different goals, and a literal wall between them with a small hatch. Okay, so there's a hatch over here, right? And where food gets passed through. Okay, so kitchen's job is cook as many dishes as possible. The more they produce the output, better they look. Okay, and the waiter's job is make sure customers are happy and no cold food is there, and also no mistakes, no complaints. Now, every time the kitchen sends something new through that hatch, a new dish or a new recipe, it's a risk for the waiters. What if customers don't like it? So, waiters start slowing things down. They double check, sending things back, and in this way, kitchen gets frustrated and waiter gets frustrated, and the customer is just sitting and waiting for their food. Right? This restaurant is actually was software companies before DevOps. So, kitchen was the dev team and the waiters was the operations team, right? Let's say it is backstage and this is front stage. Now, the backstage dev team, their job was to build features, ship new things, and the operation teams were the waiters, and their job was to keep everything running smoothly, no crashes, and no downtime. And that wall between them, literally, it was called the wall of confusion. Developers finished building something, threw it over to the ops team, and their involvement basically ended. And ops would spend days figuring out how to actually run it in the real world. And if something breaks, and something always breaks, both teams pointed to each other. And Dev said that it worked on a machine. You must have heard this phrase before, that it worked on a machine. And the operation team is saying, your machine isn't what millions of users are onto, is it? So nothing get fixed, and just a cycle of blame is going on. And this wasn't one bad company, this was the entire industry at that time. So let's understand the quick history, the model which every company was following back then. So, first, the waterfall model was being followed by every company. Then came the agile model, and after that, finally, the DevOps model was there. Right? Three phases. Let's quickly understand this. The waterfall model was uh, introduced in 70s, 80s, or 90s. You spend months writing down the every code or requirement, then you design everything, then developers code everything, and then we test, right? And after the testing, then comes the deployment. So start to finish, it may take 18 months, or sometimes it can take 2 years. Okay, so you only find out after this when you delivered and you developed your project or your product. Then after 2 years, what you find out, that you have built the right thing at the very end, by which point the market has moved, because it took around 2 years to develop this. What the client needed in 2024 was outdated, because currently we are in 2026, and uh, the product which you developed, it was outdated. So what they need to know, Now you have just handed them something that's already outdated, right? After this, when they understand there was a limitation with waterfall model, they moved ahead and created another model which is called agile model, which was around 2001. Okay, a group of developers got fed up and said, why are we planning everything upfront when we know things will change? So instead of one massive 18-month of release, we should work in 2 weeks of cycles, right? And build a small piece, show it, get feedback, right? And adjust and repeat accordingly. So this was a massive improvement and development teams got faster. Clients were also involved into this, and instead of waiting for the product for 2 years, they were also involved in this process. So it's fixed how software gets built. It did absolutely nothing for how software gets delivered, right? So developers were finishing the code every 2 weeks, but operation teams, the ops team, were still waiting and still doing that huge, scary, and manual deployments every few months. They were adding the change request and were getting approvals from the committees. There were 2 a.m. maintenance every day. Then, and there were also only 4 people who are involved in this, and they are working back and forth, and just they are trying to resolve the issues, and they are trying to make the application running, right? So in this way, development sped up, but everything after development stayed exactly. The deployment process was same exact. So to eliminate this issue, around in 2008, or let's say in 2009, a model DevOps came into the picture, and someone finally asked, why are build it, and run it two different process? Okay, why are they running completely into separate worlds? What if the people who wrote the software were also responsible for what happened after it's delivered? And what if they owned it end to end, right? So someone who is working or writing the code or building the code, they should also be able to deploy that code, right? And that question is where DevOps came into the picture, and it solved a big problem. So moving ahead with the next topic, which is what actually DevOps is, right? We understood why DevOps was needed in the market, what was the limitations and issues with the earlier models. Okay, we understood one example where how dev team and ops team interact with each other, or how they work uh, onto a new product, and how the blame cycle was going on and on, right? So we understood DevOps was the one thing which resolved all of these problems. Now, when the interviewer asks, what is actually DevOps? Then what should be your answer? So let me clear you one thing, or not, maybe three things, that DevOps is not a job title. I know I have seen this many times that company writes up that we are hiring a senior DevOps engineer. Okay, so the senior DevOps engineer is now responsible to handle everything, and that one person only is now alone and overwhelmed instead of being a whole team, right? So it is very clear that DevOps is not a single person. It is not a work of a single person, right? Second thing is DevOps is not a tool. Okay, if the interviewer asks, sometimes people answer that DevOps is using Jenkins or Docker or Kubernetes. No, actually, you are very wrong. Those are tools that support DevOps. They are not DevOps itself, right? And here comes the third point. DevOps it is not just deliver your code. Deliver your code without any rules, without any rules. DevOps actually has more quality checks than a traditional development. They are just automated so they happen without slowing you down. So again, let me ask you this question. What is DevOps? DevOps is a culture, okay? DevOps is a culture, a way of working where building software and running software are not two separate worlds anymore. We have shared responsibility, we have shared tools, and when something breaks in production, it's not dev's problem or ops problem, it's everyone's problem. And that shared ownership is what changes everything. And with this, we have our next very important topic, which is the DevOps lifecycle. In one of my interviews, I was asked this question that, okay, a new project is going to onboard in your company, then how are you going to plan the discovery and how are you going to implement or create that product from end to end, and what is the process? And the answer is the DevOps lifecycle, where the first part is planning, right? So planning is what are we building next and why, not what the dev team feels like working on. It actually is what do users actually need, right? What is breaking or what's slowing people down. In DevOps, planning is short and continuous. Okay, 2 weeks at a time and small chunks. In small chunks, you prepare your code or develop your code, and the cycle keeps on going, right? And here's what makes it different, that it is fed by the real data from the production, like what are users clicking, where are they dropping off, and what errors are spiking. Correct? So planning is done. Moving ahead with the next step is development. Developers write their code, but in DevOps, how they write it matters. So we should have small and frequent changes, not one developer disappearing for 3 weeks and working on a massive feature. Instead, we should write a small piece, get it reviewed, merge it, and move to the next one. Smaller changes are easier to review, and when something breaks, you know exactly what caused it because not much changed. Every change is tracked in version control. Who changed what, okay, and when and why. So that if something breaks in production, version control is how you find what changed it and you can roll it back to your previous version where everything was working fine. Now the third step is build. You have done the development. Now comes the build. So code on a developer's laptop doesn't just run on a server, isn't it? It needs to be compiled, okay? Compiled plus packaged and prepared. So build takes the raw code, it takes the raw code and turns it into something deployable. Correct? And it's fully automated, right? So every time the code is pushed, the build kicks off and automatically, and no human intervention is there and no manual triggers are there. Why? Because manual builds are basically inconsistent and automated builds are identical every single time. So what we understood, that there is no manual process involved in build, okay, and instead we use automated builds so that we can remove the human errors, right? And also automated builds are every time identical, they will not produce different results if the building an application, the way of building an application is similar. Moving ahead with the fourth point, which is testing. You have developed the code, you have built the application, now comes the testing. There are three layers of testing, okay, basically four. The first one is unit test, which checks individual pieces of logic, right? Now comes the integration test. What it does, it checks if different parts talk to each other correctly or not. And comes end-to-end testing, where you check if the whole user flow actually works or not. And the fourth is we have security tests, where these tests are meant to scan vulnerabilities. We have hundreds of checks due to which your application runs smoothly, right? And if any test fails, the pipeline should stop immediately right there, and code will not move forward until it's fixed. Moving ahead with the fifth point, which is release. Okay, tests are passed and build succeeded, but is your application ready to release? And here comes two different things, which basically defines how releases are handled in any of the IT company. First is continuous delivery. Okay, it means the code is always ready to deploy, but someone still clicks the button and deploy the application. Okay, the next part is continuous deployment. Continuous deployment, which means if it passes, it goes automatically and there is no button in between. Where continuous delivery had the button, continuous deployment basically focuses majorly on automation, right? And in IT companies, most team starts with continuous delivery. Next point is deployment, which is our sixth point, where this is actually where the code goes live. And this is where traditional teams have nightmares, because DevOps makes deployment boring, and boring is exactly what you want. So there are three techniques that make this deployment possible, which are majorly used. There are multiple techniques, but these are the three which are majorly used by the IT companies. One is blue-green deployment, where you have two identical environments and blue is live, where green has the new version. Okay, so you can switch your traffic instantly, and if something breaks, switch back, and due to which you face zero downtime. The next deployment technique is canary, where you send the new version. Okay, you send the new version to only 5% of the users, right? And watch the numbers. If everything is fine, then you roll out to every other people. Okay, the 95% of people. And if something is off, you can just pull it back, and most users will never know. Now, third comes the rolling deployment strategy, where you update servers one by one. You update any of your new feature one by one. Okay, and if something fails, the rest are still on the older version, right? So in this way, it is controlled, it is reversible. You face low risk, and every time you can follow these steps to maybe uh, smoothen your process of deployment, right? Seventh part is operations. Okay, so your software is live now, and now someone keeps it running. In DevOps, the people who built it stay involved in running it, not handed off to a separate team, because nobody understands the system better than the people who wrote it. And if something breaks, the person who wrote that code, who wrote that application, or who deployed that application is responsible to handle that as well, not handing off to someone else, and the other person is only reading the handover document and trying to fix the issue. So this was the basic problem or the major problem which were being faced earlier, that everyone used to blame each other, right? And we understood how So operation also means like infrastructure as code, where you provision your servers, your networking configurations and everything else, and it is defined in a code. Okay, so how you provision your infrastructure is basically defined in a code, and then this can also be version controlled, so that if you want to provision your resources or your infrastructure, you can anytime roll back to the previous one. Or if you want to manage your resources in such a way that multiple teams can collaborate, then version control is the one technique where every company follows, so that your infra is up and running all the time, right? Which also helps you to make your code repeatable, correct? And with this, we move ahead with the 8th point, which is monitoring. Monitoring. Okay, so in monitoring, there are two levels. One is basic and other is observability, right? So the basic monitoring is the app up? How fast is it responding? Or how many errors we got in the last 5 minutes, right? But in observability, it goes deeper. Not just is something wrong, but why is it wrong? Which service is slow? Which query is taking too long? We can see the logs, the traces, and the metrics using observability, and it helps us to find out the issues. Moving ahead with our last point is feedback, and it is a loop, right? Feedback is a loop. Why? Because there are two sources of feedback. One is system feedback. Okay. Next is user feedback. Clear? So system feedback is whatever the data we get from monitoring, like your error rates or performance or usage patterns, this is called system feedback. And user feedback is real people, the real customers. Whenever your application is live, the real customers uses them, the real users uses them, and they provide feedback. Okay, and they will tell you that what is working and what isn't. Okay, and if something is not working, they raise the support tickets. Okay, and also they can review how the application is working, or is it working fine or not. So this was basically the 9 stages of DevOps lifecycle, correct? And that's loop. So this loop, which we have seen over here, is very important that we should understand this. And every cycle, so this particular 9 stages are repeated in cycle, and in every cycle the software improves, and it gets better and better. So in every cycle the team gets faster, your software becomes faster, and your software becomes much better. Maybe the first loop can be slow, because in the process of understanding each and every stage, implementing each and every stage, it is difficult, right? And the initial errors or issues or the initial discoveries are the one which takes time to get resolved, or maybe to implement some of these uh, uh, solutions. But first loop can be slow, but by the end of 10th or 20th loop, the team and the product becomes much and much faster and better. This is what the DevOps lifecycle is. Now, quickly, let's move to the next topic, which is DevOps tools. As you are learning DevOps, so you may come across multiple tools or multiple names which are popular in the market and being used, so that you carry out this particular stages or this life cycle, right? So for source control or version source control, we use GitHub, okay, Git and GitLab, GitLab, right? For CI/CD pipelines, What do we use? We use GitHub Actions, right? Jenkins, your AWS code pipeline, or your Azure pipelines, okay, or GitLab CI as well, which are basically popular in the market. And uh, these tools help you to automate the build, tests, and deploys. Now, very infamous topic, which is containerization. Okay, you must have heard Docker and Kubernetes. This is the soul of new age deployment, where Docker packages your app and Kubernetes is responsible to manage your apps at scale. Correct? Now comes infrastructure as code. So, a very popular tool, Terraform, is there, or you can have AWS Cloud Formation, right? In OpenStack, we use Heat templates. In Azure, we use ARM, which means Azure Resource Manager templates, and there are other tools as well, right? For config management, for configuration management, what do we use? The most popular tool is Ansible, and maybe you can use Chef or Puppet as well. Now, for monitoring, the very famous tool is Grafana, which helps you to visualize and it creates a dashboard. Okay, then comes Prometheus, and also somewhat Datadog is popular these days. Now, every single one of these tools solves one specific part of the DevOps lifecycle we have seen just now. And to be very precise and clear, none of these tools are DevOps itself, right? Maybe a new person who doesn't know about the DevOps may say that I'm using Git, I'm using Jenkins, Docker, Kubernetes, and Terraform. This is what DevOps is, right? But the person is completely wrong. Why? Because DevOps is not using the tools, but it is a culture. Okay. So think about how often your apps update on your phone, like Netflix or Instagram, right? Or Facebook. So these apps get updated, right? And they are constantly improving. The bugs are disappearing, new features are appearing, and you barely notice it. Why? Because this is where DevOps come into the picture, and DevOps help these infamous tech companies to implement the DevOps culture and help them to update or get constantly improve. So once again, DevOps is not a job title, it is not a tool, not a one-time setup. It's a culture where building and running software are the same team's problem, and it is connected by automation, and it is driven by feedback, which should be always moving, right? So if you like this content, subscribe to my channel, and we will see you in the next one.